This is Biology 223, Genetics, and this is a problem we're going to do. It's a problem from a sample recitation problem, and we're going to do part F only here. And this is actually a repeat of a previous video in which I used a method that's a little bit sloppy and I made a mistake. So I want to show this as an example of how to approach these problems such that there's a very systematic method, a method that discourages mistakes. So there's a pedigree of 6 generations of Drosophila shown. Of interest are loci A, B, C, and D. Locus A is autosomal. So notice that we're concerned with question F only here, which is only loci C and B. They should have been alphabetical order, but so ignore A here. Locus B and C are X-linked, 20 map units apart, so that's important. Locus D is Y-linked. We don't care about that, so we don't need to pay attention to it at all. That's the point. That's a primary point. We're asked about C and B. We're not asked about anything else. We ignore it. It doesn't matter. You can be asked how many things are square and how many things are red, and it doesn't ask you how many things are tall and how many things are short. Just answer what you're asked. In parts A through E, which includes, that should be F, the parts of the genotypes of all members of generation 1 are known, and the genotypes of their descendants are to be calculated. Okay, so it tells us here. So we're not looking at, we don't care about A, we don't care about B, we care about C and B. So let's notate that. So I'm going to write out the genotypes of all here, and I'm for D. I'm just going to have Y because we don't care. Plus B, plus plus, plus plus Y, plus 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 plus, C plus for Y, plus plus over plus plus, and plus plus over Y. So the method here will be using Punnett squares, calculating the likelihood of a specific genotype, and keeping track of gametes, probability of gametes. We're asked specifically about the genotype, the likelihood of this individual here, 5-2, being CB over plus plus. Note that that is not, we are not asked C plus over plus B. That's different. We're not asked the likelihood of this individual being heterozygous at C and B. That would be different. We're asked specifically about CB over plus plus, that cis-trans is different. So notice that specifically that genotype, which includes that C and B are on the same chromosome. So I'm only going to, because we're asked a specific question, we don't care what the genotype of this individual is directly. We care only what the gametes that this individual can produce, and that's important. So when we look at individual 1-1 also, so if we care about her, we care about this chain, her ancestors. We don't care about these individuals, so we can neglect. We don't care about him. It doesn't matter. He's not an ancestor, not an ancestor. I may occasionally pretend these are people. Notice that the issue of Drosophila males not undergoing recombination is not an issue here because it's X-linked. So this just as well could be a human pedigree and everything would be the same, because in humans, the male is being hemizygous in X like Drosophila. There's no crossing over. So we care only about what gamete she can make. So she can make a wild type gamete. He can make wild type or Y. In this case, he only makes Y because his descendant is male. Likewise, this individual, she can make plus B or plus plus. We only care about his plus plus. Here, only plus plus. Here he does have a male descendant, so we care about both plus plus and plus plus. So those are all taken care of. He then he can make gametes. We care about his genotype only to the extent that he is son. So the only gametes we care about that he can produce are Y. It doesn't matter his mother. He has a son only that's relevant here. So we only care about the Y. Here, she is, and we're going to do a Punnett square. I'll do it off to the side here. So let's do individual 3-1. So individual 3-1, and it's very useful to keep track of this. The mother, whoops, we haven't got there yet, sorry. So I didn't get that far. Let me go back and start with individual 2-2. So she, from her mother, she can be either 1/2 chance of plus B, 1/2 chance of plus plus, and the father, it can only produce a plus plus gamete resulting in a female. So we have plus B over plus plus and plus plus over plus plus. Therefore, she has, and this is 1 out of 1, so we have a 1/2 chance of her being this and a 1/2 chance of being this. And so let's do it this way. She can produce, what kind of gametes can she produce? I'll use this as a symbol. She can make wild type, homozygous wild type, or plus B. So what's the likelihood of that? It's going to be, the likelihood of making this gamete is going to be, we can see it as 1/4, but I can draw you through it. It's going to be 1/2 chance of being this genotype, and if this genotype, 1/2 chance of producing that gamete and 1/2 of that. So that's going to be 1/4 because that's 1/2 times 1/2. And the chance of making a plus plus gamete is going to be 1/2 chance, 1 times 1/2, and 1/2 times 1/2. So that's going to be 3/4. So that means I'm calculating, I can just look at it here, 1, 2, 3. Look, there's no crossing over here either because there's only one heterozygous locus. Can't have crossing over that's meaningful. Be very careful. People make mistakes here. So we could count this up here by saying, well, the contributions are going to be the 1/2 chance of being this genotype times 1/2 chance if this genotype are producing that gamete, plus the 1/2 chance of being this genotype multiplied by the chance of producing that gamete, which is 1, and so that leads to 3/4. So that's easy. In other cases, I might, if there's no recombination, I would just say 3-1. I'd say she's her genotypes, or what we care about her only is what gamete she can produce. I'd say 3 plus plus 1 plus B. That works, but I'm going to keep it a little more strict here. 3/4 plus plus 1/4 plus B, so that we don't get confused. And notice, because the male offspring has a Y from the male, the gametes that she can produce are the same as the gametes he can produce. So we've already done her male offspring, 3/4 chance of plus plus and 1/4 chance of plus B. That's him. Let's go over to finished generation 2. So he will inherit from his mother a plus plus, and from the father a Y. This individual was plus plus over plus plus, can only produce plus plus gametes. Therefore, this person we don't care about because they're not a descendant. Therefore, this individual would get a plus plus from the mother and a Y from the other. So the gamete we care about is plus plus. Okay, now I'm going to take a little shortcut here. He can only produce plus plus, and the individual we're asked about at the end here is CB over plus plus. So that means there's a 1 out of 1 chance that to get this genotype, this individual inherited it from the father, if I will. So really the question then becomes the likelihood of this genotype for individual 5-2 is the likelihood of the female parent being able to produce gamete CB, and we're almost there. So likewise, going back to individual 3-2, so let's go here, individual 3-2 here, 3-2, the parent here, one parent, the female parent can produce only plus plus, and the male parent can produce only C plus, therefore plus plus over C plus, and the gametes that she can make are going to be 1/2 chance of plus plus and 1/2 chance of C plus. Okay, that's fine. So we have her plus plus and C plus. Now the one we care about, what's this individual? So this is individual 4-1. Individual 4-1, remember from the mother, we just determined that, 1/2 chance of plus plus, 1/2 chance of C plus. From the father, we already figured that out, didn't we? Father, she gets only, where did she get that from the father? He is here, so his gametes are here, so there's a 3/4 chance of a wild type homozygous and a 1/4 chance of plus B. So the offspring, she, that's her genotypes here, will be plus plus over plus plus, plus plus over plus B, plus plus over C plus, and C plus over plus B. We're asked about the likelihood of this individual being CB over plus plus. We already figured out the plus plus, so it's about the likelihood of her inheriting the gamete, inheriting CB from female parent, which is the likelihood of crossing out this genotype, the likelihood of being this, of 4-1 being this genotype, and if this genotype producing the CB gamete. Okay, so if this genotype, so what's the likelihood of this genotype? This is going to be 1/2 times 1/4. So 1/2 times 1/4. 1/4. And if this genotype, well, then it gets back to there, 20 map units. So if this genotype is C plus over plus B, the gametes will be C plus plus B, recombination to make homozygous wild type, and to make CB. These two are parental, these two are recombinant. We're told 20 map units, so these two together should be 20%. So separately, it should be 1/10. Notice I'm using fractions. I could use decimals, but it gets a little bit confusing, and I find that it's just a lot neater to use fractions of whole numbers. So the likelihood of if this genotype producing this gamete is 1/10, so that's going to be 1/10. So that is the 1/10. This 1/4 is here. This 1/2 in here. If we the product of that 1/2 times 1/4 times 1/10 is 1/80. So the answer is 1/80. So the likelihood of individual 5-2 being genotype CB over plus plus is equal to 1/80. I will finish.